Have you ever wondered what actually holds the entire universe together? I mean, we all think we know the answer, right? It's gravity. But for decades, there's been this enormous cosmic mystery hiding in plain sight that suggests one of two things. Either 95% of our universe is completely missing, or our entire understanding of gravity is just wrong. So let's dive into the evidence that's threatening to break physics as we know it.
Okay, so here's the whole problem in one simple picture. On the left, that's what we think should be happening. Based on all the stars and gas we can see, a star's speed should drop the further it gets from the galaxy's center. You see that nice downward curve? But then you look at what we actually see out there in the universe. That's the graph on the right. The line is flat. The stars on the outer edges are moving just as fast as the ones closer in. So fast they should be literally flung off into the void. And yet, they aren't.
So this leaves us with a huge, nagging question. If our theories of gravity from Newton and Einstein are correct, then there has to be some kind of invisible glue, some massive amount of extra stuff that's providing the gravitational pull to hold these spinning galaxies together. So what on earth is it?
Well, this leads us to the standard explanation, the idea that physicists have been working with for decades now. It's called the dark matter hypothesis.
The theory is pretty straightforward. It says that every galaxy, including our own, is sitting inside a giant invisible cloud, a halo, of this mysterious substance called dark matter. We can't see it, we can't touch it, it doesn't interact with light, but it has mass. And its gravity is supposedly what's keeping everything from flying apart. It's a really elegant solution, you know? It makes all the math work out perfectly. There's just one tiny little problem. After decades of searching with some of the most sensitive detectors ever built, we haven't found a single particle of it. Nothing. Zilch. And this chart right here really puts the scale of the problem into perspective. I mean, look at this. The stuff we're made of, every star, every planet, every single one of us, that's only 5% of the entire cosmic recipe. According to our best model, 27% is this dark matter we can't find, and a whopping 68% is something called dark energy, which is a whole other mystery. Just think about that. All of our physics, everything we thought we understood, is built on just 5% of what's actually out there.
And that brings us to a much more radical and honestly, way more interesting alternative. What if we've been looking for the wrong thing this whole time? What if there is no missing matter? What if the problem isn't with the universe, but with our understanding of its most fundamental rules, like gravity itself?
This is where the theoretical physicist, Erik Verlinde, enters the picture. He's proposing that we've been thinking about gravity completely backward. He suggests that maybe, just maybe, gravity isn't a fundamental force of nature at all. Maybe it's something else entirely, something that emerges.
So what in the world is emergence? Well, it's actually a super powerful concept. It just means that you can get complex, large-scale behaviors to arise from very simple underlying rules. Think about temperature, for example. A single individual water molecule doesn't have a temperature. The idea is meaningless for one molecule. But you get a whole bunch of them bouncing around together, and suddenly the concept of temperature emerges from their collective motion.
Here's a great way to visualize it. If you look at reality really, really close up, it might be just like this image, just a bunch of simple colored squares, pixels. On their own, they don't mean a thing.
But then you step back, you zoom out, and all of a sudden, a coherent picture emerges from those same simple pixels. A landscape. That landscape doesn't exist in any single pixel. It's a property of the whole system working together. Verlinde's wild idea is this. What if space, time, and even gravity itself are just like this landscape, emerging from something much more basic underneath? And this leads to a really deep insight. What if our physical laws aren't absolute, unchanging truths? This quote suggests that they're really just descriptions of how things seem to behave on our human scale, on our time scale. But what happens when you zoom out? I mean, way, way out to cosmic time scales. This brings us to what I think is a brilliant analogy. Silly putty. You remember that stuff, right? If you roll it into a ball and throw it at the wall, it bounces. It acts like a solid. That's how it behaves on a short time scale. But if you take that exact same ball and leave it on your desk for a few hours, it flattens out and flows like a puddle of liquid. Its properties completely change depending on the timescale you're looking at. So here it is, the big idea. What if gravity is the universe's silly putty? Einstein's amazing theory of general relativity, that's the bounce.
It perfectly describes how gravity works on short timescales, like planets zipping around a star. But over the immense billion-year timescale of a galaxy slowly rotating, maybe gravity starts to flow. Maybe it behaves differently. And maybe that extra gravitational pull we've been calling dark matter isn't matter at all. It's just gravity acting in this new emergent way over cosmic time.
Okay, so if gravity emerges, what does it emerge from? This is where the theory gets really mind-bending. It's the idea that reality at its core isn't built from particles or energy, but from something even more fundamental, information itself.
The biggest clue for this whole idea actually came from studying black holes. First, we know they have a surface, the event horizon. Then, brilliant physicists like Stephen Hawking and Jacob Bekenstein discovered something incredible. The area of that surface is directly related to its entropy. Now, entropy is usually talked about as disorder, but in physics, it has a much deeper meaning. It's a precise measure of information, how much data you can pack into a system. So hold on, if the surface area of a gravitational object tells you its information capacity, then gravity and information have to be deeply connected.
This theory proposes that the pixels of our universe, the most fundamental thing there is, are units of quantum information. We call them qubits. Think of them as the universe's most basic ones and zeros. And the connections between them, this bizarre quantum link called entanglement, is what actually weaves the fabric of spacetime. In this view, reality isn't made of things. It's made of the relationships between bits of information.
So, let's bring it all back. How does the strange new picture of an information-based universe actually solve our original mystery about galaxies spinning too fast?
Well, in this new picture, there is no dark matter. It doesn't exist. The extra gravity we see holding galaxies together is an emergent force. It's an effect created by all these complex patterns of entanglement in the quantum information that fills all of space. The normal matter in a galaxy just kind of disturbs this underlying information field, and that causes a gravitational kickback that's stronger than what Einstein's theory alone would predict. It's a theory that might finally connect the huge cosmic world of gravity with the tiny, microscopic world of quantum physics.
So let's just lay it all out nice and simple. This table shows the two worldviews, side by side. In the old view, gravity is a fundamental force. Space-time is a smooth sheet, and dark matter is some mysterious particle we have to hunt for. In the new view, gravity is an emergent phenomenon. Space-time is built from quantum bits, and dark matter is just an illusion, an effect of gravity's different behavior on the biggest scales.
So why does any of this matter? Well, because if this theory or something like it turns out to be right, it's not just a clever explanation for dark matter. It would be the biggest shift in how we see reality in over 100 years.
You see, the physics of the 20th century was all about reductionism, breaking things down to their smallest possible parts, particles and forces. This new perspective suggests there's a deeper layer to it all. It's a huge shift from a universe made of stuff to a universe made of information. The particles and forces we see might just be the emergent output of an underlying quantum code. And that leaves us with one final, truly provocative thought to chew on. If space, time, and gravity are all just emergent properties of entangled quantum bits, what does that really mean for us? Are we living inside some kind of cosmic computer? Is reality itself just an unbelievably complex program running on some kind of fundamental cosmic code? That is a question that the next revolution in physics will have to answer.